Right, greetings all. Welcome back to the machine shop. There's the latest update on what we're up to and what we're on with. Okay, right, first up, we've got the bit of a progress report on these new safety valves. Barry's been machining for 825. Actually, I'll correct myself. New safety valve bases and valves, because here's one of the bases, like I showed you last week. And then here's a new valve that Barry's machined up from raw casting. You can see the valve seat there and then the skirt around the outside of it. Now, as I said before with these, by setting the clearance between that skirt and the base here is how you get these valves to work properly. That is, vent, open, and then close with that sharp pop when they release enough pressure. So there's one that's done, and there's the matching twin. So I haven't actually seen Barry this week, so I don't actually know if these are ready to go or not, but they certainly look ready to go. And then another job he's got on is this aluminium box here. Now this is for a new AWS local unit. I believe it's going to end up on 806 eventually. Now, a very good supporter of the railway had made these up, and so what Barry's got is just a couple little internal modifications and whatnot to make them suitable for use. They're aluminium. You can see where they've been welded up. You can also see that front panel with this. That's the indicator. We call it the sunflower, which tells you what state the AWS is in, whether it's alarmed or clear. That's been CNC machined from another piece of aluminium. So Barry's just got that to modify for some internal bits, and then that's ready to go. Right, so here's the next challenge. What we need is a new one of these that's slightly more hexagonal. This is a spring hanger nut off 825, and to get it off, the lads ended up gas axing two of the corners off. The idea here was this causes the nut to expand. It also gives them something to get a nice tight hold of the set of Stilsons, and so they can then sway the nut off. Unfortunately, unsurprisingly, neither us nor Network Rail will be terribly happy with that being put on, so we need a new one. To do that, we've taken it's actually an offcut of some EN19 left over from another job, and what I've done is quickly rough turned it in the lathe. I've put a step in one end of it. This will be machined off the finished nut. This step is purely to give us something to hold it by, because it was quite a short billet. And then this section here, via the use of the marvel of an online calculator, which, if I remember, I'll look up the link for, I know the across flats dimension of the nut. That's 2 3/4 inches. And using said online calculator, I can calculate what I call the across corners dimension of the nut. That is the nut from there to there. And so that then tells me the diameter, the minimum diameter that this billet needs to be turned to. It works out at 3.17 something. I can't remember the exact something. I think it's 175, but don't quote me on that. And because I'm me and I tend to always round it up, it was rounded up to 3 1/4 inches to rough machine the billet down to. So that's been turned to that, set up with the dividing head. Now, it may look slightly strange here. First of all, quick word on the dividing head for those who haven't seen one before. The idea of a dividing head is it's an accessory used on a milling machine to rotate a piece of work in very precise increments. Now, it might be for a nice simple job like this, where we're putting hexagon onto something, and so we can rotate it in 60-degree increments very accurately, or we might be, I don't know, gear cutting, say, or putting spline on the end of a shaft. And so the idea is, when you rotate this handle here, this handle drives a worm gear in the body here, which in turn drives another gear, which is mounted onto this spindle here. So when you rotate that handle there, this chuck will rotate. Now, there's two ways of indexing it. The first is a rough and ready detent ring here, where there's a detent pin that engages in a series of holes in this ring. So you can increment, so he says, trying to do the maths in his head, you can rotate it in 20-degree increments, or alternatively, you've got this wonderful array where in this disc you have these rings of holes. Each of these circles of holes has a particular number of holes within it, and so you can set it up so it's 2 complete turns and 5 holes on the whatever, I don't know, 27 hole ring will give you precisely this many degrees. To be honest, to work that out, you really need all your brain cells lined up and working. It's actually quite a convoluted process to work out what you need there. But once you've got that, you can set up any number of rotary divisions, rotary increments, incredibly accurately and incredibly easily. Very handy bit of kit. So anyway, so I've got that bolted down for its milling machine. We've got the work set up in there, and the other lump we've got here is the tailstock. Works exactly as the tailstock on a lathe does. The idea here is, because I haven't got the biggest grip on that piece of work, the danger is that as I go in with the cutter, the work will try and kick out this way. It'll try and push the work out towards me rather than cutting it. And so what the tailstock does here is that's rigidly bolted down to the table of the mill machine, just like a lathe tailstock. You turn the handle, winds the screw thread, pushes that centre into the work. So that tailstock is pushing the work hard back into the chuck. And because the chuck jaws are up against this shoulder here, can't move. So at that point, it's shorted. Can't move, can't go anywhere. Tight as a bishop's codpiece, as my old boss would have said. So that's the idea, and hopefully the next time you see that, it'll have a hexagon on it. Right, there you go. As promised, it's now got a hexagon on it. It's remarkably easy to mill hexagons using this setup. All you have to do is touch off, that is, advance the work into the tool until the tool just starts cutting, and then that gives you a reference for your start. What you then do is, well, if you already know the diameter of the billet, which we did, and you know the across flat size of the hexagon, which we also did, all you have to do is subtract one from the other, and then because you're in effect cutting the billet on both sides, top and bottom, you divide that by 2, and that gives you the cut to put on to end up the hexagon the right size. Now, when I say put the cut on, what do I actually mean? Well, what I mean is you're advancing the work into the cutter so that when that work is traversed across the cutter, remember, on a milling machine, it's the cutter that rotates and the work that moves. It will then cut metal off. Now, to advance the work, we use this hand wheel here. Now, what this does is, if you just step back from a moment, I'll show you do a quick anatomy of the milling machine. We have the table here. That sits on the saddle, which in turn sits on the knee, which is that big lump with the hand wheel sticking straight at it where my finger is, and the second hand wheel off to the left. Now, what these hand wheels do is they're each connected to a lead screw, and one of those lead screws, when wound, causes part of the machine to move. This hand wheel is the Y, or cross movement. When I wind this, the table will move longitudinally like that. And this one is the Z, or vertical movement. So what I do is, there is a scale on there, as you can see. It's actually set for the last cut, which was a cut of just over 31 and a half to be absolutely precise. And yes, you can split thous in your cuts with dials if you know what you're doing. Anyway, so basically by winding this hand wheel, it transmits power down a shaft here, into some bevel gears somewhere in the bowels of the knee, which in turn then engage with a whopping great lead screw that's about 2 inches diameter, and that in turn causes the whole shebang, the knee, the saddle, the table, to rise on the column behind it. That's, you can just see the slideways there that the whole mass rises on. And so by lifting that 100 thou, when you then use excuse me, when you then use this hand wheel to wind the table backwards and forwards, you will put on a cut and rinse and repeat several times, well, 6 times to be exact, and rotating it 60 degrees every time, you end up with a hexagon. What I then tend to do is then, this has actually been done in 3 cuts. 2 cuts of 100 thou depth of cut, and 1 finishing cut of 31.5 thou. That was just how it worked out. 100 thou is about the deepest cut I'll be prepared to take. I always like to leave a little bit for a finishing cut, because if you take a shallower cut, you'll end up with a better finish. So at that point, that's the hexagon done, finished. All we've now got to do is whip it out there, drill a hole up the middle, which is the core size of the thread, and then we've just got to internally screw cut the thread. So that'll be the next stage, which we'll see done in the very near future. So, and then here's one last job that we're on with. These are you remember I waved a camera at these drawings a while ago? These are the temporary boiler stays for Hartland, which I went into the boiler shop the other week and pointed a camera at the boiler so I could see where they're actually going, what they're doing. Now, Craig and Brian have been on with these when they've been in over the last couple of weeks, and here's a couple that have been done. There's quite a few more been made. They're actually in the boiler doing the job. These ones are just the latest batch, waiting for Will to collect them. This nut, incidentally, was produced by Will using the taps, which will be used to tap the holes in the boiler, so we know basically it's a go, no-go gauge. If it fits into that without too much rattle, it's spot on, and these are. So they've been done and ready to go, and there's a pile of blanks that Brian was on with the other week, sorting out, centre drilling and tidying up so they're all ready to go. And there's the threading tool we'll be using. So, somebody was asking the other week about why do we need these, and I maybe wasn't as complete in the explanation as I could do. It's a bit complicated and will take considerably longer than this video to explain exactly why. The short answer is, first of all, the existing stays are, some of the replacement stays need to be made of monel. That's A, quite expensive, and B, there's quite a considerable lead time on getting it and getting them made. So these serve as a very quick stopgap to do the job. Second, the plates may try and move slightly during welding. If they move and damage one of these stays, it isn't a problem at all. If they move and damage a monel stay, it is a problem because first of all, monel is very hard to machine, very hard to drill, so it'll be a struggle to get it out. Then second, you've got the replacement cost of the stay. Whereas if they write one of these off, well, there's about, very little cost of materials and very little time has been spent on them so far. So there's that. The quantity of stays required, there's quite a considerable lead time on getting those ordered. So in turn, we don't know exactly how many we'll need, and so these are the quick and easy way of getting the job done. All the holes haven't been tapped yet, so Will's going along tapping as he can, and if he suddenly discovers that one needs to be tapped up a size, well, that's not a problem because we can very quickly rattle one of these out a size bigger, no problems at all. And the idea is that we'll be able to leapfrog these along as they weld more and more of the back head in. We'll also be able to leapfrog these along, and so make it, well, basically, yeah, we won't need as many of them as we would stay. So that's maybe not the best explanation, but hopefully it'll clear up any last remaining. Why aren't we putting the proper stays in? There is method in the madness, honest. It just sometimes might take a wee bit to come out. So anyway, so that's the other job we're on with at the moment. So anyway, as always, folks. Oh, and sorry, Dan Middle was also on with the last of the valve rings as well. There's another cast iron pot that Dan's busily turning into rings. So I'm not quite sure what that's going into. It's going into either Repton or 825, and I'm not quite sure which. I say Repton or 825 because they're the last two engines we've got in pieces at the moment. So I'm not quite sure which one that's going into, but I'm sure it's going into something southern. So anyway, folks, there we are. That's where we're up to, and that's where we're at. Hope you found it educational, informative as always. Now take care, and I'll see you around.